get A1, A2. So I can get them here. A1, 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 A2. Now notice that reuse is allowed in the sense that this guy here, these two here, A1, A1 covered that, and these two here, A1, A2 covered that. Even though this A1 had already, quote unquote, been used, okay, but it doesn't matter. You're not trying to cover these things independent of anything else. You're just trying to force all possible transitions of length 2, in this particular case, to have been taken. Whether they were taken as part of doing something else doesn't matter. You just want to make sure that they've been done. Okay? Here we see B8, A1, and B8, A2. So there it is there. All right. See how that works? So you continue this process until you've covered all of these guys, you see here in the red, and then you're done. Okay. And I noticed the last time I ran this course that this last test here actually is incorrect. It's missing a B3 because it ends up in A9, puts you in the B state. So this should actually have a B3 here to get you into the E state. Because remember, the rule, which we inherited from our tests initially, was you got to get to the final state to be done with the test. Okay, so I just point out there is a missing transition here, a B3 transition to get me to the E state. Okay. All right. Now, let me just mention another point here. Equivalence partitioning and boundary value analysis can be applied to state diagrams. In general, you know, any set of testing techniques can be blended together to generate tests, and you should always feel free to do that. So, for example, you think of the pay good event. Now, notice I'm showing this in a little oval here, but this is not a state. Pay good was actually an event condition combination in the diagram, right? I can do equivalence partitioning on that if I support 4 different credit cards, and I can say, well, I want to have a good payment, in other words, a processed payment that covers all 4 of the supporting credit cards, American Express, MasterCard, Visa, and Discover, right? So that would be an example of applying equivalence partitioning to this event condition combination. Similarly, I could look at purchase good and purchase bad, and I could say, well, I could do boundary value analysis on the amount, because maybe I've got some ranges defined for what's the minimum and maximum purchase. See? So I could say, well, clearly, somebody tries to make a negative purchase, then that's not right. So I want to test the negative, some big maximum negative number, and then you know, minus 1 cent. And then 0 is always interesting, right? So that's its own invalid here. And then 1 cent up to $9.99, assuming that $10 is my minimum, right? And then I want to test a $10 purchase and a $10,000 purchase. And then if that $10,000 is the max, then I want to test a $10,001 just overflowing the shopping cart, and then some really huge number. Okay, so that would be a combination of boundary value analysis, state transition technique, which is always legitimate and certainly something that you can do. Now, the previous presentation, the previous webinar on this topic, I discussed state diagrams, and the question that sometimes comes up is, or excuse me, I discussed decision tables, and the question that sometimes comes up is, well, should I use a state-based technique or should I use decision tables? And there are certainly cases where it's sort of a matter of personal preference. A ATM, for example, can typically be modeled either as a state diagram or as a decision table, and it's really up to you how you want to do it. What will happen is, as the number of states increases, if you're going to try to use a decision table, then you end up using the conditions in the decision table to try to monitor the states. And that gets cumbersome after a while because what happens is that the number of conditions starts to really grow in the decision table. And especially if you're going to try to create a full decision table that shows all combinations of conditions, you start to get a lot of can't happen kind of combinations occurring because you can't be in two states at once. It's also true that the state-based technique, as a general rule, I'm not saying this always applies, but most of the time, if you use both a decision table and a state transition diagram to model a system and then generate your tests from it, you'll find that the state-based techniques will generate more tests than the decision table-based techniques. Now, that can be either good or bad. If you're trying to do a more cursory sort of test, then maybe you want to generate fewer tests and you want to use the decision table rather than the state diagram. Now, in some cases, though, you'll just see that either one technique or the other is the obvious choice. The general rule is that a decision table is ideal for situations that are transactional. And by transactional, I mean that there's a given set of things that happen pretty much all at once that create some conditions, and then the system takes certain actions based on those conditions, and then that's that. And then the next clump of conditions that are handled are not influenced by whatever happened previously. Okay? And for systems that are not transactional, where what has happened so far very heavily influences what's supposed to happen next, then you want to use a state diagram. So that's the general rule of thumb. It's not hard and fast by any means, but it's a good general rule of thumb. Transactional systems are decision tables, non-transactional systems are state diagrams. Okay, so we looked at the state diagrams. We looked at tables. We looked at switch coverage and use of those on sophisticated and potentially complex systems. State diagrams are especially useful for embedded systems of various kinds, or systems that run for extended periods of time, handling a particular operation. Right, so you can imagine that a tape backup system or any sort of backup system would be a good fit for state diagram, right? Because you're setting up the job, and then you're backing up, and then you're comparing the files that were backed up against the backup, and that's obviously a good fit for a state diagram. Okay, so we've now looked at decision tables and state-based methods, and so in the next webinar, which I say here will be the final webinar, but it probably won't because it's pretty popular, so I'm going to extend it out a couple more. The next one will look at use cases, and that will also be a good way of testing business logic, so that'll be another technique that you want to have available to you. Okay, so as always, I'm going to go ahead and put the advertisements up here while we do the Q&A. That's the presentation, and I'll let the folks here in CA start with the first set of questions if people have any.